As you move past the Pythagorean theorem questions, you'll notice that at the top of the page, it notates it as Unit 2. So now we're moving into the second unit that we covered this year. And as we move through, we're going to move into congruence statements. So what we have here is a hexagon that is the image of the other under a 270-degree rotation about point Z. So point Z is that sort of point of pivot. So it looks like we went down this way. So what happens? Who matches up? And really what I want to know is, where does A match up with? So if you look carefully and you kind of match up, E matches up with K, F matches up with L, then it looks like A is probably going to match up with G, and then B is going to match up with H. And that's the key piece. Then AB is going to go to GH. And then I can just kind of keep following along over to I, J, and so on and so forth here. And what I'm going to do now is use that to answer the rest of the questions. So for angle, FED is congruent to angle, and F is the last position, ED, we're just going from last backwards 3 positions. So I'm going to start at the last letter here and then work my way backwards 3 positions to get the 3 letters that go right here. Conversely, or along the same lines, I should say, not conversely, HI is in the second and third position, so that looks like it probably matches up with BC. And I just want to copy the notation. Segment HI is congruent to segment BC. So on and so forth. Copying the notation that I got, measure of angle. So I got measure of angle, and then I'm looking for the 3 letters that match up with the positions of L, G, and H. So I'm going to go find L, G, and H in this, look at their numbered positions, and then try to match them up with 3 letters that match up similarly in A through F. And that's how you're going to answer that. Keep in mind that order matters, right? Order matters in these questions. Here we're going to just keep in mind that we're naming triangles by their side names and by their angle names. So just to run through from your notes, you have 3 side names. They're going to be scalene, isosceles, and equilateral, right? Lateral means sides. So equilateral has 3 sides congruent, isosceles has 2 sides congruent, and a scalene, of course, has no sides congruent. Then we have our angle names. So we're going to have acute, and remember that an acute triangle has 3 acute angles. Obtuse is going to have 1 obtuse angle. A right triangle is going to have 1 right angle. And then you have the equiangular, which, keep in mind, all of them are, right, 3 congruent angles. They're all 60 degrees, by the way. So all equiangular triangles are also referred to as acute, if you would like to. So I take a look at, say, this problem right here, and what do I notice? I notice that 57 is acute, 79 is acute, 44 is acute, right? They're all less than 90 degrees. So that's going to indicate that we have an acute by angle name. Now for side lengths, I notice that I got a 6.1, 8.7, and 7.4. None are alike, so we're going to say scalene. Now if all 3 angles are different, then all 3 side lengths are also going to be different. All right, so all triangle names, or all triangles, should have 2 names in this section. One refers to its sides and one refers to its angles. So one from the blue section and one from the red section. And this next question just asks you to identify this triangle as isosceles if it is, or if it's equilateral, or perhaps if it's scalene. So what we're going to need are some side length pieces of information. Now again, how you choose to go about this is up to you. You can use the distance formula, but I would suggest that for the length of this side, you just create a right triangle, and for the length of this side, just create a right triangle, and for the length of this side, just create a right triangle. Now, when can you not use the right triangle trick? If all we did was give you the actual coordinates, right? If we just said A was 4, 7, and B was 10, 3, and C was 6, negative 3, and we didn't give you a grid, then you would have to engage in the distance formula. So one or the other. But the Pythagorean theorem is a little bit easier. So if you just count side lengths and figure out the length of AB, so you're going to need the length of AB as an answer. You're going to need the length of BC or CB as an answer, and you're going to need the length of AC as an answer. And depending on how many of these are congruent will depend on whether or not you say it's isosceles, equilateral, or scalene. Now, if it is equilateral or scalene, keep in mind, if I had a equilateral triangle that looked like this, and these were the two congruent sides, and it happened to be A, B, C like this, then what angles would be congruent? The angles opposite the congruent sides. So those would be the two angles. And so for part B, it says name a pair of congruent angles. Well, any pair that's actually congruent satisfies the answer. If it happens to be equilateral, right, then all three sides would be congruent and all three angles opposite those sides would be congruent. So you could name any pair, which is two, right? Name a pair of congruent angles. So I think if we're asking for a pair of congruent angles, then there must be either an isosceles or equilateral triangle present. Okay, make sure you show your work. On this next question, what's most important, I want to draw your attention to questions D, E, and F. And accidentally labeled angles AEG, and angle AEG would be right there, and that's not an angle that we're really referring to in this picture. What I meant to type in there was AGE, so we keep referring to this angle right here. And it's been given that the AGE or EGA is 65 degrees. Okay, so keep in mind that 65 degrees is in several places in this diagram, and then there's one other distinct angle measure. So I would fill in the whole diagram, right? And by that I mean, I know that this is also 65 degrees, and it goes elsewhere in the diagram. So label 65 everywhere it goes, and then, of course, to get the other angle measure, it's going to be 180 minus 65 is some answer, and that's going to go in the other 4 places. So there should be 4 places that have 65 degrees and 4 that have that other value. And then we just start going along the lines of alternate interior angles, alternate exterior, corresponding vertical, yada, yada, yada. For A, B, and C, all you have to do is just name the angle that's alternate interior. Name the angle, name the angle. For D, we want you to find the measure of the angle, and then we want you to identify its relationship with respect to that first given angle. So DHF is where? DHF is right here. So let's call this angle 1, and let's call the given angle angle 2. What is the relationship between those two? Well, those are alternate exterior. And I know that alternate exterior lines, or alternate exterior angles of parallel lines, AB, it's been given, is parallel to CD, so these are parallel. I know that these two are congruent angles. So obviously then the measure of angle DHF is equal to 65 degrees. So that's what we're looking for there. All right. So you should be able to get the rest of that based on that reference. This next section, we're talking about triangle congruence theorems. So keep in mind we have side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg for right triangles only. And keep in mind that the order of these letters matters, right? So for right here, that angle has to be the included angle, right? The angle between the two congruent sides. This would have to be the included side, right? The congruent pair of sides that is included between the two congruent angles. And then angle, angle, side would be 2 pairs of angles that are congruent followed by the congruent angle. So take, for instance, B. Can you prove that these 2 triangles are congruent? Well, first I see that I have a pair of sides, right? So I'll say I got an S there. And then I notice that I have a pair of angles given to me. So I have a pair of angles. I also have another pair of vertical angles that I know, right? Remember, you have to bring some things to the plate as well. Maybe if it's a shared side, you have a pair of sides that are congruent that aren't necessarily marked. So we have another pair of angles. And so I have two angles and an S. So if I have two angles and an S, I could use angle side angle or angle angle side depending on how things are ordered. So it looks like as I move from one pair of angles and I travel to the next pair of angles, that side is not congruent. It's not the included side. I'm going to leave the side till the end. And over here, I have to check both triangles. The double angle marching over to my single tick arced angle to my single tick mark side. It looks like that is angle angle side. So can you prove it? Yes. If so, which theorem? Angle angle side. You do the rest. So the last piece of advice here. This is a shared side. It's not marked congruent, but it's the same side on both triangles. So you be the judge of what to do with that. I'm not saying that this is a yes or a no. I'm just saying that there is another pair of sides that have not yet been marked. And that concludes the review for Unit 2. On to Unit 3.